Imagine for a moment you're nestled inside a spacecraft millions of miles from Earth. The rhythmic hum of life support systems is a constant, reassuring lullaby. Outside, an infinite black canvas stretches, dotted with distant, glittering stars. And then, a flicker, a wispy tendril of smoke snaking its way from a control panel. It doesn't rise upwards as it would on Earth, but expands ominously into a spherical cloud. Panic tightens your chest. This isn't just a fire, this is a potential death sentence unfolding in the ultimate enclosed environment. This is the nightmare scenario that keeps astronauts awake and space engineers constantly striving for perfection. One of the worst things that could possibly happen on a spaceship is a fire. In the confined, oxygen-rich, and equipment-dense environment of a spacecraft, a blaze can quickly spread, suffocating occupants, melting vital support systems, and transforming an isolated haven into a burning tomb. The consequences are immediate and devastating. Lives lost, billions of dollars of equipment destroyed, and the future of human space exploration brought to an abrupt halt. Now, here's the paradox, the truly intriguing part. NASA's bold, almost unbelievable plan to prevent such a disaster is to safely light the International Space Station on fire. Yep, you heard that right. Deliberately, scientifically, and with immense caution, they intend to ignite flames aboard our most advanced orbiting laboratory. This audacious project has been aptly named SOFIE, that's S-O-F-I-E, standing for Solid Fuel Ignition and Extinction. It's not some rogue, uncontrolled blaze. Oh no. These SOFIE experiments are meticulously carried out within the ISS's specialized combustion integrated rack, a kind of laboratory within a laboratory, designed specifically to contain and control these very sensitive trials. The fundamental reason behind this seemingly counterintuitive approach lies in the unique behavior of fire in microgravity. On Earth, a flame dances upwards, driven by convection. Hot gases rise, pulling in fresh oxygen from below. This creates a predictable shape and direction for the flame. But in the microgravity of space, there's no up or down. Hot gases don't rise, they simply linger around the flame. This can have peculiar effects. Sometimes a flame might suffocate itself in its own byproducts, leading to a weaker burn. Other times, without the buoyant force pulling fresh air from below, it spreads out in unexpected spherical shapes, consuming oxygen from all directions. This unpredictable, often slower, but potentially more insidious behavior makes predicting and fighting fires in space an entirely different beast. We simply don't fully understand it yet, and that lack of understanding is a massive risk. Scientists hope that by observing these controlled burns, they can learn precisely how fire spreads and acts with various materials while in low gravity. The materials chosen for testing are those commonly found on spacecraft: different fabrics, electrical wire insulation, plexiglass-like plastics, and various types of organic and inorganic solids. Each material will be subjected to controlled ignition sources within the sealed environment of the rack, allowing researchers to monitor everything from flame propagation speed and temperature to the chemical byproducts released. High-speed cameras capture every flicker, while sensors meticulously record the data. Think of it as a series of miniature isolated fires, each providing invaluable data points that contribute to a larger, life-saving puzzle. The end goal is monumental: to establish safe, self-sustaining human colonies on the Moon and Mars with minimal risk of fire destroying everything. If we are to truly become an interplanetary species, we need to design habitats and vehicles that are inherently resistant to fire in an environment where evacuation is simply not an option. The knowledge gained from SOFIE will directly inform the design of future spacecraft and deep space habitats. It will help engineers select the most fire-resistant materials for construction, develop more effective fire suppression systems tailored for microgravity, and refine emergency protocols for astronauts. Imagine designing an entire lunar base where every component, from the wires running through the walls to the fabric of the sleeping bags, has been tested and certified for its fire safety in a low-gravity environment. That's the future SOFIE is helping to build. This remarkable endeavor, setting a controlled fire in space to prevent a catastrophic one, is a profound testament to human ingenuity and our unwavering drive to explore. It's a vivid example of how we must understand our environment, even its most destructive elements, to safely venture further into the cosmos. The lessons learned from SOFI will not only make current space missions safer, but will lay crucial groundwork for humanity's ambitious future outposts, those colonies we envision establishing on the Moon and Mars. It's about designing a future where the dream of living among the stars isn't shadowed by the devastating specter of uncontrolled fire. It's about conquering one of our most primal fears through the meticulous, thoughtful application of science. What are your thoughts on this incredible balance of risk and reward? Does the idea of fire on the ISS make you nervous, or does it inspire you with the boldness of scientific pursuit? Share your insights in the comments below. And if you found this story thought-provoking, please consider subscribing for more journeys into the remarkable world of space exploration and scientific discovery. Your support helps us continue to share these fascinating stories. Thank you for listening.